So we're going to visit this GeoGebra.org dice roll simulation, and essentially we are basically going to have it do some things for us here. So let's give it a moment. Alright, so the first thing we're going to do is we're going to roll, this is a 6-sided die, and I only want to do one, so I'm going to take the slider here and move it over to a 1. And then once I have only a single die, then I'm going to roll the dice 10 times. So I'm going to click on the 10. And notice, not too badly distributed, right? Not exactly even, right? We would expect for the theoretical probability to get the same number of 1s as 2s, as 3s, as 4s, as 5s, as 6s. And so I can see that I rolled a 3 2 times. So if I want to calculate the probability of rolling a 3, that would be 2 out of 10. Okay, I'm going to do this. I'm going to hit roll a dice another 100 times and look at the distribution here, the frequency of each of these rolls. So I got a 1 19 times, I got a 2 24 times, I rolled a 3 19 times, etc., etc. So now if I want to calculate the probability of rolling a 3, then that's out of 19 out of 110. So that's not quite exactly 1 out of 6, right? It's close. I think we do a quick calculation here. Let me grab my calculator. When I calculate 19 divided by 110, I get 0.17. 1 divided by 6 is 0.16 repeating. So we're pretty close, not exact, right? Now let's hit 10,000. Notice the bars start to become about the same size. And now if I take a look at the 3, the frequency of the 3, it was 1,634. And if I divide that by 10,110, I get 0.1616, which is pretty darn close to 0.16 repeating. And if I did it another 10,000 times, let's see what I would get. Let's see, 3, I got 3,290 divided by 20,110. 0.1636. So again, I'm getting closer to that 0.166 repeating. And if we kept doing this over and over, we would eventually get really sufficiently close to that, right? We could change this to show the relative frequency. And so it takes away the bar graphs and just puts the decimal equivalent, the relative frequency, essentially the probability, experimental probability of rolling a 3 was 0.164. And if I hit 10,000 again, I get 0.162, 10,000 again, I still stay at 1.162, and if I do the frequency back again, we start to see, again, these bars are starting to really come very close to each other. They're very similar, right? Not a whole lot of differences there. And again, if I go back to relative frequency, there's not much of a change there. But they're all fairly close to 0.166, right? Repeating, 0.167, 0.166, 0.165, right? All very close to that. And so that's really what the law of large numbers says, that if I do this experiment of rolling a die, a 6-sided die, and I calculate the probability based on those results, those trials, that probability, that relative frequency, is going to approach what the theoretical probability was, or the idealized probability would be. And so that's just a nice little simulation.